Hello everyone, welcome to In 5 Minutes. In this video we are going to see another topic on differential equation, that is making the equation exact. So as you have watched previous few videos, in that used to find the partial derivative of m with respect to y and partial derivative of n with respect to x, and you used to check whether both of these are equal or not, and till now we have seen that both of these are always equal. So that means our differential equation is exact. But now these two will not be equal. That is, our equation is not exact. So any problem we will see from now, partial derivative of m and partial derivative of n will not be equal. That is, our differential equation will not be exact. So for that type of problem, what we are going to do? We are going to make this not exact differential equation, we are going to make it exact by multiplying some integrating factor. What is integrating factor? Integrating factor is nothing but it is a common factor of m and n, which when multiplied by m and multiplied by n, so we will get new m1 and n1. So this new m1 and n1, we again find these values and these two will be equal. So as you can see, to somehow we have to make our equation exact even if it is not exact. So to make equation exact, that is forcefully we have to make this equation exact. So by forcefully means we multiply not exact equation by multiply by integrating factor. So we multiply not exact equation by integrating factor, we will get the new values of m1 and n1. Then if we take the partial derivative of m1 and n1, both this will be equal, and then our equation will become exact. So we know that for exact differential equation, the solution is given by integration of m treating y as constant plus integration of n neglecting all the terms which has x. So the solution remains the same, it's just the sum modification we need to do when the equation is not exact. In this type of problem we have three subtypes, that is how to find integrating factor. For that we have three types. So the first type to find the integrating factor is that when our equation is m dx plus n dy equal to 0, when this equation is not exact, and we can represent this equation is in the form function of x comma y taking y outside the function into dx plus function of x comma y taking x constant into dy equal to 0. If this m dx plus n dy equal to 0 is not exact, and if we can represent this equation in this form, then the integrating factor is nothing but 1 upon m into x minus n into y. So this is one of the subtype of finding an integrating factor. So after finding this integrating factor, we multiply integrating factor by m. We multiply this integrating factor with this. Okay, so now our new equation will become something different. Let's say m1 dx plus n1 dy equal to 0. After this we will find partial differentiation of m1 with respect to y and partial differentiation of n1 with respect to x, and we will check whether these two are equal. When these two will be equal, then our solution will be given by integration of m treating y as constant plus integration of n neglecting the terms which has x. So this is the first type in which we will make our not exact equation into exact differential equation. The problem on this type we will see in our next video, so stay tuned for our future lectures.